Hello AP Comers, we're going to talk about Lewis acids and bases. So there are three definitions for acids and bases. We've already covered two. The first definition is the simplest one, the Arrhenius definition. It says that an acid gives off H pluses in water, whereas a base gives off OH minuses in water. Then we talked about Bronsted-Lowry, where we have this acid-base conjugate pairs, and an acid is a proton donor, whereas a base is a proton acceptor. And so that included many bases that did not have hydroxide groups. Now we're going to talk about Lewis acids and bases. Unfortunately, those are out of the AP exam, but they are very, very important in general chemistry in college because they include acids that don't have hydrogens and bases that you would not think would be bases. A lot of those are organic molecules, and you do not need aqueous solutions in order for these to be considered acids and bases. So they are more inclusive than the other definitions we've done. So you need to know this for my test, but you do not need to know it for the final exam or for the AP exam. So a Lewis acid is an electron pair acceptor. And so Lewis acids and bases talk about electrons as opposed to protons. And because electrons are kind of the opposite of a proton is positive, whereas an electron is negative. And so the definitions are flipped. So a Lewis acid is an electron pair acceptor. And a base is an electron pair donor. So the definitions are kind of flipped from the Bronsted-Lowry because an acid, according to Bronsted-Lowry, is a proton donor, but now it's an electron acceptor. And a base, according to Bronsted-Lowry, is a proton acceptor. Now it's an electron donor. So it's a little bit confusing in that regard. So an example of a Lewis acid and base, for example, is the reaction between H plus and NH3 to yield NH4 plus. So let me rewrite this a little bit differently. Sorry, my stylus is not working too well. So here it is, the H plus the ammonia, the NH3, the lone pair on the ammonia there, yields NH4 plus. And so in this case, this is an acid because it's an electron pair acceptor. This is a base because it's an electron pair donor. So in a Lewis base, the base will have a pair of electrons in order to donate them. And so right here, those electrons are going to be donated to the hydrogen. And so that is what is going to make the bond between that hydrogen and that nitrogen. And so the nitrogen gave away its electrons, so it's a electron pair donor. The hydrogen accepted that pair of electrons, and so that's an electron pair acceptor. Therefore, that H plus was an acid, and that nitrogen with a lone pair was a base, according to the Lewis definition. So let's practice a few of those. I'm going to draw them, and then we can decide whether they are Lewis acids and bases. So here are the four structures drawn. Let's start with pH 3. So pH 3 right here, we want to determine whether it's a Lewis acid and base. We also, just to review for fun, we want to determine its hybridization, electron geometry, molecular geometry for each of these. So let's start with pH 3. And so we want to determine if it's a Lewis acid and base. And so, sorry, a Lewis acid or base. And so to determine that, we want to see if we have an electron pair to donate, or if there's a vacancy for it to accept an electron pair. And so right here we can tell that it does have an electron pair to donate. And so this is going to be a Lewis base. Let's review the electron geometry. And so there are 4 areas of electrons, and so that would be tetrahedral for the electron geometry, but it only has 3 bonds, and so that's going to make a trigonal pyramidal shape. And the hybridization, since there are 4 areas of electrons, it's going to be an sp3. Okay, let's move on to the next one. BCl3 is right here. So first, to determine if it's a Lewis acid or base, we check if it has a lone pair that it can donate or a vacancy that we can give it electrons. So it does not have a lone pair to donate, and also since it has 3 areas of electrons there, it can accept another pair of electrons to get its octet. So that definitely will be a Lewis acid. Let's review its hybridization and electron geometry. So there are 3 areas of electrons there, and so that would be an sp2 hybrid. And 3 areas of electrons would be a trigonal planar, and that would apply for the electron geometry and the molecular geometry both. Okay, let's move on to the next one, H2S. So this one would be a Lewis base, and the reason for that is because we have a couple of pairs of electrons that we can donate. So it can be an electron donor. And then for the hybridization, there are 4 areas of electrons around it, so that's sp3. And 4 areas of electrons for the electron geometry, that would be tetrahedral. But since there are only 2 bonds, that would be a bent shape for the molecule. And the last one here, we do have an electron pair that we can donate right there, and so that would be a Lewis base as well. And for the areas of electrons, we have 1, 2, 3, 4, 5. So that would be an sp3d, which they would not ask you about on the AP exam. Anything above sp3 you wouldn't be asked about. For the electron geometry, that would be with 5 areas, it would be trigonal bipyramidal. And for the molecular geometry, that would look like a seesaw. That is it for the acids and bases chapter. I will see you in class soon.